can we actually make Mars Earth-like through terraforming? Mars, around 3.5 to 4 billion years ago, was thought to have liquid water. The landscape today shows supporting evidence that Mars once had oceans, rivers, and lakes. Looking at Mars from planet Earth through a telescope, you would have seen an emanating blue array of light transforming the red planet to what it is known as today, to a glorious ecological wonder of imaginative beauty. Mars was once a world, combined with a thick atmosphere shielded from radiation with a magnetic field, plus a variety of organic molecules. Mars had the enormous favourable potential to support life as found on planet Earth. Therefore, with human advancements in scientific understanding, this raises the question, could Mars once again be allowed to curate its own world with a little push? Unfortunately, Mars probably did not remain habitable for very long. Approximately 3 to 4 billion years ago, the red planet lost its own magnetic field. This allowed solar winds to strip the planet's atmosphere and water, turning Mars into, well, a red, barren, chilly planet that we know of today. If humanity embarked upon terraforming Mars into a once potential biodiverse world, what would it really take? Well, let's take a look. First, heating Mars to hold liquid water. Currently, with an atmospheric pressure of 0.6% of Earth's, the atmosphere of Mars is just way too thin to support liquid water. An idea once mentioned by Elon Musk was to essentially source nuclear bombs to explode over the ice caps of Mars. The idea is the nuclear explosion would take place over the polar caps in space. The radiation from the explosion would eradicate into space, while the heat emanating from the explosion would melt the ice caps into, well, a liquid state, whilst vaporizing the carbon dioxide into the atmosphere, creating, well, a greenhouse warming effect. The concept of vaporizing the poles to produce carbon-rich atmosphere raises many scientific questions though. The ice caps hold an enormous amount of water, enough to cover the surface of Mars to, well, a few tens of meters deep. However, the main concern is that of the carbon dioxide released, the conditions wouldn't hold for very long, as the carbon released would only be, well, thought to double the atmospheric pressure to what it is today. The atmospheric conditioning would still not really be enough to hold water in a liquid or vaporized state. As explored by NASA and ESA, satellite data for 20 years, the emerging evidence throughout the years showed signs that there being an abundance of carbon sources held in the material soils and tightly bounded carbon minerals. However, even if all the carbon was somehow mined, and the atmosphere on Mars would still only hold around 14% of that on Earth. A 14% atmosphere would be a good place to start though, but would only see a temperature rise of around 10 degrees Celsius, nowhere near warm enough to hold liquid water. Future advancements in science and technology may hold the answer to this problem, whereas others do believe other sources of carbon can be found on Mars, through mining asteroids or redirecting near carbon-rich asteroids or comets towards Mars. Second, we're going to look at, could we breathe on Mars? There is currently technological research aiming to convert carbon dioxide extracted from the atmosphere into oxygen. Although this concept offers a great opportunity to explore planets like Mars, we would need to look more closely to home to really understand the biodiversity of gases' oxygen-rich cycle for, well, the long-term purpose. Earth transformed into an oxygen-rich atmosphere from an atmosphere dense in ammonia and methane. This transformation holds credit to the cyanobacteria and the evolved chemical process known as photosynthesis, which was thought to have occurred, well, around 2.5 billion years ago. At this stage, Mars was already dry, red and dusty. Introducing these species to Mars with the right atmosphere could hold true to support the beginnings of breathable air and even diverse life. The consideration that Mars is an extreme environment that receives less sunlight than Earth and has several weathered dust storms that block out sunlight for various periods mean that photosynthesizing organisms would need to be adapted to thrive to these conditions, which was once the case on Earth. Introducing specialized cyanobacteria and extremophiles could, well, be the step forward. Although some scientists do believe that this feat advance once conditions change, with just one favourable blend of grass to allow the diverse of life to evolve and, well, to environmental conditions on Mars. However, we must remember that evolution has its mind of its own, guiding organisms to adapt to conditions on Mars in a favourable way to thrive in a new environment. The new environment over many thousands of years just may not be favourable for humanity. And last, we're going to look at the magnetic field problem. The slow eradication of magnetic field on Mars, as mentioned, was the result of a dusty red environment on Mars in the first place. Even if humanity was to solve this issue of liquid water and breathable air, it just wouldn't last long, as the magnetic field on Mars just isn't strong enough to protect the atmosphere from the solar winds. There have been several theories suggested, such as placing a large enough asteroid between Mars and the Sun to direct much more of the solar wind around Mars. However, this just may not be practical and would come in many problems itself. Studies have shown that even today Mars is losing its magnetic field. Maybe this is just one of those scientific technological quests that just doesn't have the answer as yet. To terraform Mars into a biodiverse that imitates Earth just may not be probable. However, more research and future explorations to the planet may reveal more about, well, the past present of life that may have or may be occurring. The more we learn and understand Mars and its environment, the more advanced we will be in taking steps forward into other planetary explorations. If you like this video or videos like these, then please hit the subscribe and like the video. And remember, stay curiously minded. Until next time.